And this question, actually, there's a couple of parts to it. The first part is, what value can we put for R sub out that will produce the maximum power to the circuit? And the second part, what will happen if we let R sub out equals 3K? How much power is delivered to that? And the third part, once we make R sub out equals the correct value for maximum power, can you tell me what that power is? So to find the value for R sub out to maximize the power, you need to find R thevenin. So I'm going to cut the circuit right here and thevenize this portion of the circuit. So I'm going to take this and replace it now with a voltage source of V thevenin with the resistor of R thevenin and this is your R sub out. So let's find V thevenin first. V thevenin is V open circuit. That's what V thevenin. So if I chop the circuit, this is my V thevenin right here, plus to minus, which is V open circuit. Now, since that's an open circuit, there's no current going through this. There's only one current in the circuit. That's this current. Let's see if I can find that current. As I'm traveling clockwise, going to mark it plus to minus. This doesn't change here, plus to minus. So 2K times I plus 20 plus 30 plus 2K times I is equal to 0. 4K times I equals what? Negative, right? I equals negative 12.5 milliamp, I think, right? Which means the current is going to be going which way? Upward. So I can redraw the circuits. I don't have to keep flipping back and forth. I don't want to keep going back to that page, so I can put it away now. Here we go. We said the current is 12.5 milliamp going which way? Upward. So we have a current going this way, 12.5 milliamp, positive. Notice I defined it coming down, that was a minus, which means going up is what? Plus. So if this is my ground here, this voltage, we'll call it Vx, and we'll call this Vy. The current's going up is going to mark the resistor which way? Plus to minus. It's going upward. That means Vx is going to be lower than this, going to be negative, because this is 0. So Vx is going to be 2 times 12.5, which is what? 25. Negative 25 volts. The voltage right here, plus to minus, is going to be 2 times 12.5, which is 25. Plus to minus. That means this end is going to be 25 volts lower than that end. Vy now Vy is going to be what?
5 volts.
This end is going to be 30 volts higher than that end. So it's going to be Vx plus 30. And yes, that would be negative 25 plus the 30, which is plus 5 volts. And this is my V open circuit. This is ground. If I know what the voltage there, the difference between them, that's V open circuit. So whatever that voltage is my V open circuit. So my V open circuit here, this end is going to be what? 40 volts lower than this. So it's going to be Vy minus the 40. Vy is 5. 5 minus 40, which is what? Negative 35 volts. That's V open circuit, which means V thevenin equals negative 35 volts. So we found V thevenin. Next, we need to find R thevenin. For maximum power, I need to find the Thevenin equivalent. And R out is going to equal R thevenin. So when you only have independent sources, R thevenin is what? You kill all the sources and you find R equivalent. So that should be a quick way. Let's kill all the sources. The voltage source becomes a short circuit. So here's the 2K. Let's kill that source, short circuit. Let's kill this source, short circuit. Let's kill the 40 volt source. And what is R thevenin? Looking that way. What is that R?
1K.
It's 2K in parallel with 2K, so it's the product over the sum. So R thevenin is 1K. So for maximum power transfer, you want the source here, V thevenin, which is what? Negative 35 volts. This is R thevenin, which is what? 1K. You want to replace R sub out with what? To be 1K. For maximum power transfer, you want R out to equal R thevenin. So that's the value of R. That will give you maximum power. Let's calculate what the power to this load. This is the load here. What is the power delivered to that load? The power to the load, we said, is what? V thevenin squared divided by 4 times R sub L. We derived that last time. V thevenin is negative 35 squared divided by what? 4,000? $35 squared divided by 4,000. it is 0.30625 watts. So you can write that what? In milliwatts, 306 what? Milliwatts. Now, the other part, second part, what will happen if we go back to that circuit and we make the original circuit? Where is it? Here. It says, how much power is delivered to this if we make this, what, 3K? Okay. So let's look at that part. How much power? Is delivered to R out if we make R out equals 3K. Well, guess what? The first half of the circuit is not changing. So I can still use the Thevenin equivalent of that. What's the Thevenin equivalent of that? Negative 35 and 1K, right? Now, if you put a 3K here, can we get what the current through it or the voltage? Because if you know the voltage, V squared over R. So let me see if I can find that voltage. I call it VL. I can do voltage division. VL equals what? This is V Thevenin. This is R Thevenin. And this is RL, R out, whatever they want to call it. Equals V Thevenin times that resistor over the sum of both them. Voltage division. Negative 35 times what? 3 over 4. (35) times 3 divided by 4. It's a negative 26.25. And what is the power delivered to that load? It's VL squared divided by R sub L. Negative 26.25, when you square it, that's a positive number, divided by what? 3K. And this one is 0.230 roughly, or 230 milliwatts.
Why is it over 4 on this time?
That resistor is 3 now. The other one, we derived it. I'll come back and explain that after. Why is it 4? I'll come back to that question after I finish with this one. And the next one is, can you give me a number for R sub L that if I plug it in, the power will be 20 milliwatts? So that's the third part. This is part B here. Let's look at part C. Part C says, find the value of R sub L to produce a power to the load of equal 20 or 200? 20 milliwatts. negative 35. This is 1K R thevenin. This is R sub L. We're not sure what that number. The reason why we divide by 4K on the previous one, because if these guys are equal, what's the voltage here? Half of that number, right? So V thevenin over 2. When you square that voltage, what's 2 squared? 4. That's where the 4 came in. So here, VL here is going to be what? It's going to be negative 35 times what? R sub L over the sum of them, which is R sub L plus 1,000 or 1K. And your power is going to be VL squared divided by R sub L. Well, if you square that number, you'll have negative 35 squared times R sub L squared over RL plus 1,000 squared. And you're going to divide it by R sub L. Well, when you divide by R sub L, that's the same as multiplying by 1 over R sub L. So the math says, oh, this number is going to be, what's 35 squared? 35 squared, 1225, times R sub L, this will cancel one of these, over R sub L plus 1,000 squared. And for this part, we want the power to be what? 20 milliwatts. 20 milli, that means 20 over what? 1,000. Or 0.2 if you want to. 0.02, I'm sorry. So now we just got to do our math. You'll have a quadratic equation, that's why you're probably going to have two answers. Cross multiply. I can simplify first. That's 1 over what, 50? Make my life easy. And cross multiply. 1 times that, it doesn't change it. $50 times 1225, 6125, 0 R sub L. And now we have a quadratic equation. This is square that, R sub L squared. 2,000 times, is it 2 times this? 2,000 R sub L plus square that one. Square that one's not a million. Equals 61250 R sub L. Subtract 2,000 from both sides. Subtract 61,000 from both sides. Now you have a quadratic equation. RL squared plus, is that 59,000? Minus, not a plus. Minus 59,250 R sub L plus 1 million equals to 0. Use a quadratic formula, minus b, 59,250 plus or minus the square root If you have a built-in app that will solve a quadratic equation, plug it in. Minus 4 times A times C all divided by 2 times A. $59,250 plus or minus, let's see what that number. Square that number. Minus 4 million. Take the square root of that number. 59216. Over 2. So one value is going to be the positive, one value is going to be the negative. 59250 plus 59216 divided by 2. One value is 59,233. The other one, 59250 minus 59216 divided by 2. The other one is 17.
I get it.
17 ohm and 59K. So this is 59.2 kilo ohms, and this is just 17 ohms. These are the two values. The reason you're going to have two answers, if you probably monitor the power there, as R changes, well, this is what you're going to see. R load, there's the 1,000. Remember the maximum power, we said at 1,000, and what was the value of that power? We calculated that power to be what? 306 milliwatts? 306. So if this is the 306 somewhere here, power here, you're going to find the power looking like this. This is the maximum value, so I got to go higher. Then start to decrease. That's why we're saying what value of R sub L will give you a power of 20. This is a 20 milliwatts. So we have two resistors. We have this value. We also have that value. That's why one of them is 17. The other one is 59,233. Any one of those numbers you pick between 0 and 306, you're going to have two answers because we're looking at that line. What value will give me a power here? If I said, what's the power? What's the value that give me this much power? Go, that much power? It's going to be this resistor and that resistor. Two numbers. But for maximum power, there's only one value, and that's when R sub L equals 1,000. We can do this in mathematics or MATLAB, take the expression. We know what the equation, we just derive that, and just have R changes. If I had MATLAB on this machine, I would have done it in 2 seconds. Graph it. Where is it? I just derive the equation for it. Right there. This one. There's the power. And just tell them to change. Take this equation, plot it as R sub L goes from 0 to, I don't know, 60,000. And see what will happen. Plot the power. And you'll see it will look like the curve we just graphed there. I might do that if I have time today, and I'll bring it next time. Plot it in MATLAB, takes 2 seconds, set up a loop there. R equals 0, incremented by 100 to 60,000, plot that. R sub L versus the power. Any other questions on maximum power transfer?